Hello everyone, a very good evening all of you, and a very warm welcome to you all to this wonderful session regarding your revision of the formula. So this is a unique and special session we have started last year, and students gave the tremendous response. They were very happy with this type of sessions where you will be able to memorize, you will be able to recall your formula through some questions. So those who are watching me live, please do respond through the comment section if my audio and visual quality are fine. Hi no one, good evening, welcome, kya hal chal? I hope here civil as well as mechanical students both must be there. So please mark your presence by writing in the comment section so that we can start. Audio video clear hai? If you face any difficulty, let me know beforehand through the comment section so that we can rectify the issue and the session will continue without any disturbance. All right. So this is part 1. Fluid mechanics is divided into two parts. Part 1, we will talk about some important questions or important formula through questions for this statics and kinematics, and in part 2 we will talk about the dynamics of the fluid flow, right? Hi Hari Sindhu, namaskar everyone, adab, shubh sandhya, good evening, sat sri akal, assalamu alaikum, wanakam. Please get yourself settled down fast and try to check your memory through these simple and beautiful questions. So for those who are attending my session for the very first time, this is my quick short simple introduction. I am a mechanical engineering graduate from IIT Delhi, also cleared engineering services examination, worked in Steel Authority of India Limited for a couple of years, and from last 11 years I have been into teaching, guiding the students who are preparing for various competitive examination. Yes, Krupa? Sir, I have completed total syllabus of fluid mechanics, but I did not find a better way to revise it. Please suggest me a better way. What you can do is, Krupa, if you have gone through the syllabus of fluid mechanics thoroughly, then you should start appearing for the mock test series. Practice some previous year questions, and through the question practice you will revise your fundamentals. If you will start revising page by page, it might be boring, you might not like it, but if you will solve some numericals, then automatically the revision will happen parallelly, simultaneously. Or what you can do, that is one thing. The other thing you can do is make a target of some particular topic, for an example statics, manometry, and then revise that manometry and solve some numericals from the manometry. Then kinematics, revise the kinematics completely in an hour or so, and then practice some beautiful wonderful numericals from the kinematics. So these are the two methods. क्या सिंधु क्या पूछ रहे हैं आप? When will class PE? Which PE? Production engineering you are talking about? This is my Telegram channel, you can join. Civil engineers can also join me on the Telegram because I deal with fluid mechanics as well, and which is common for mechanical and civil. चलिए start करते हैं. And you must be knowing that there will be a mock test. We have already conducted one mock test, and the next mock test will be conducted between 28th of October to 3rd of November. You just have to register yourself, and the link is already mentioned in the description box. So this is the entire schedule. This is for mechanical engineering. Civil engineers को भी already पता होगा. अभिनव नेगी सर, रिचा मैम आपको दिखाते होंगे schedule. You can take the screenshot and you should the syllabus. It is subject-wise test, some subject-wise test, and then there will be full-length mock test. And based on your performance in the mock test, you can unlock our test series for a discounted price. Production engineering. अच्छा वो सर आज शायद अवेलेबल नहीं है, कैंसिल हो गई होगी, है ना? तो धीरज सर ही बताएंगे प्रोडक्शन इंजीनियरिंग के क्लास के बारे में. आप YouTube पे क्लास की बात कर रहे हैं, मुझे आइडिया नहीं है आप किसकी बात कर रहे हैं. YouTube पे सेशन की बात कर रहे हैं तो धीरज सर मस्ट बी नोइंग अबाउट इट. Yes, the first question on the screen. Everyone, I want everyone to respond. The dimension for kinematic viscosity is the dynamic that the dimension for kinematic viscosity. What is kinematic viscosity? There are two type of viscosity. Kinematic viscosity ko we also call it as momentum diffusivity. We also call it as momentum diffusivity. कौन जानते होंगे इसको? Momentum diffusivity के नाम से mechanical engineers, because in heat transfer we use momentum diffusivity. So there is a relation between kinematic viscosity and dynamic viscosity. Kinetic viscosity is dynamic viscosity per unit density. The unit is meter square per second. SI unit is meter square per second, or CGS unit is centimeter square per second, or stock meter square per second, right? Dynamic viscosity is not a function of density. The unit of dynamic viscosity is Pascal second. The unit can also be called as kg per meter second, and CGS unit is poise, or poise can also be called as gram per centimeter second, or we can also call it as dyne second per centimeter square, or it can also be called as dyne second per centimeter square. We can also call it as Newton second per meter square, Pascal second, or Newton second per meter square, right? So this is, and kinematic viscosity is inversely proportional to density. Dynamic viscosity is independent of density. What is density? Mass per unit volume. So kinematic viscosity is independent. Kinematic viscosity depends on density, but dynamic viscosity is independent of density. 1 centimeter or 1 stock is equal to 10 to the power minus 4 meter square per second. ये conversion भी आना चाहिए आपको. And 1 poise is equal to 10 to the power minus 1 or 0.1 Pascal second. यूनिट को लेके बहुत कंफ्यूजन रहता है स्टूडेंट्स के मन में, इसलिए आई हैव टेकन दिस क्वेश्चन टू मेक यू अवेयर अबाउट द यूनिट. समटाइम्स द क्वेश्चन ओनली मेंशन दैट द विस्कोसिटी ऑफ ए फ्लूइड इज दिस. नहीं सिंधु, फ्लूइड मैकेनिक्स आज और कल है. ये फॉर्मूला मेमोरी टेस्ट का टाइमिंग हर सब्जेक्ट का अलग अलग है, हर सब्जेक्ट का टाइमिंग अलग अलग है, राइट? So this is about the kinematic and dynamic viscosity. Sometimes the question only mentions the viscosity. So the unit will decide whether it is given as dynamic or kinematic viscosity, right? The next question, decrease in temperature in general results in. Question number 2. Decrease in temperature. How the temperature varies with viscosity. The viscosity of a fluid is governed by cohesive force and molecular collision, molecular momentum transfer or molecular collision. In liquid, cohesive force dominates. In gas, collision dominates. So viscosity, if we talk about the variation of viscosity with temperature, as the temperature of the liquid increases, viscosity of the liquid will decrease. Why? Because cohesive force decreases. At higher temperature, cohesive force decreases. And as the temperature of a gas increases, viscosity of the gas will also increase. So this is how the relation is. If we draw the diagram, viscosity versus temperature, then for the liquid it is decreasing, and for the gas it is like this. This is how. What is the answer? Decrease in temperature. If the temperature decreases, temperature of the liquid decreases, then viscosity of the liquid increases. And if temperature decreases, viscosity of the liquid, if the temperature decreases, viscosity of the liquid decreases, and viscosity of the gas will, viscosity of the liquid will increase and viscosity of gas will decrease. ये होगा. So an increase in viscosity of the liquid, that is incorrect. A decrease in the viscosity of the liquid and an increase as that of gas. D तो होगा. सिंधु क्या बार बार कभी A, कभी B, कभी C, कभी D. D will be the answer. Decrease in temperature. The question says decrease in temperature. And for a gas, dynamic viscosity of a gas is directly proportional to T to the power 1 by 2. T is the absolute temperature. From the kinetic theory of gas, T is the absolute temperature, right? And kinematic viscosity of the gas is proportional to T to the power 3 by 2. Gas के लिए ये relationship भी आपको पता होना चाहिए, right? Let us move to the next one. About the capillary tube. The next question is regarding the capillary. इसलिए तो ये फॉर्मूला रिवीजन टेस्ट है, so that you will be able to recall if you have any confusion. So that will first of all, this session will make you understand what are the formula you can recollect, what are the formula you cannot. So accordingly you should focus, give more attention to the formula which you cannot recollect. Moreover, the formula, sometimes we are confused in some of the expressions, some of the formula. So you will get a clarity and you can prepare yourself accordingly. So please appear, take part in the session, share your answer. 2 का आंसर सी कैसे होगा? विस्कोसिटी ऑफ द लिक्विड और टेम्परेचर ऑफ द लिक्विड इनवर्सली रिलेटेड होते हैं. नो वन. विस्कोसिटी ऑफ द लिक्विड और टेम्परेचर ऑफ द लिक्विड इनवर्सली प्रोपोर्शनल होते हैं. यहां डिक्रीज इन टेम्परेचर बोल रखे हैं ना. टेम्परेचर डिक्रीज करेगा तो लिक्विड का विस्कोसिटी इंक्रीज करेगा और गैस का विस्कोसिटी डिक्रीज करेगा. विस्कोसिटी और टेम्परेचर डायरेक्टली रिलेटेड होते हैं गैसेस में. इजंट इट? क्वेश्चन नंबर 3. द कैपिलरी राइज और डिप्रेशन इन ए स्मॉल डायमीटर ट्यूब इज. व्हाट इज कैपिलरी राइज और फॉल? 4 सिग्मा कॉस थीटा upon rho of the liquid into G into D. That is the capillary rise or fall. It will be capillary rise when we are getting the positive value. It will be capillary fall when we are getting the value as negative. And rho into G, rho of the liquid into G is called as specific weight. मुझे बता सकते हैं what is the unit of specific weight? Rho into G is gamma, specific weight of the liquid. Or we can also call it as weight density. What is the unit of weight density? What will be the unit of weight density? अच्छा, oh sorry. अच्छा. Sorry. My mistake. सही बोल रहे हैं no one. C होगा. आंसर C होगा, D नहीं होगा. क्वेश्चन नंबर 2 का आंसर सी ही होगा, डी नहीं होगा. लिख में सही रहा हूं यहां पे, बट ऑप्शन सिलेक्शन में गलती कर दिया. हाँ, सी इज द करेक्ट आंसर. यस, नो वन. वेल डन. गुड. दैट कॉन्फिडेंस यू शुड हैव. सो वेट डेंसिटी, द यूनिट इज न्यूटन पर मीटर क्यूब. व्हाट इज वेट डेंसिटी? दैट इज वेट पर यूनिट वॉल्यूम. सो द कैपिलरी राइज और डिप्रेशन इज डायरेक्टly. व्हाट इज थीटा? Theta is called as contact angle. If theta is less than 90 degree, it means cohesion between the liquid molecules is less than adhesion. So there will be capillary rise, implies capillary rise, or the liquid is wetting liquid. The liquid is called as wetting liquid. So there will be a capillary rise. If theta is greater than 90 degree, it means cohesion is greater than adhesion, or the liquid will be called as non-wetting liquid, like mercury. Mercury is an example of non-wetting liquid. In a glass tube inserted in mercury, so the H will be negative, here H will be positive, that is capillary rise. Here it will be capillary depression because H will be negative. If theta is greater than 90 degree, cos theta will be in second quadrant. So cos theta will be negative. So it will be, what is the answer? Directly proportional to specific weight, that is incorrect. Inversely proportional to surface tension, that is also incorrect. Sigma is the surface tension. Sigma will be surface tension, that is also inversely proportional to diameter. Yes, that is correct. Directly proportional to surface area. No, it is not correct. Directly proportional to surface area, not correct. C is the correct answer. Well done. Question number 3, answer is C. Question number 4, ये तो मैंने ऐसे ही दे दिया. Question number 4 तो आप कर सकते हैं. What is the answer to question number 4? Narrow slit. What is the relation? The capillary rise in a narrow slit and capillary rise in a tube. Is there any relation between these? Question number 4. What is the answer? Question number 4. Capillary rise in case of narrow slit is equal to twice of sigma cos theta upon rho GD, rho of liquid. That is half of capillary rise in a tube. And diameter should be less than 5 mm. Diameter should be less than 5 mm, then only you will observe capillary rise or fall. So the answer is, it is half of that of capillary tube of diameter W. It is half of capillary tube of diameter W. Question number 4, option A. Question number 4, option A. Question number 5. What is the answer for question number 5? Question number 5. If I write tau is equal to A into du by dy to the power n plus b, this is the general expression. So if b is equal to 0 and n is equal to 1, it will be Newtonian fluid. It is Newtonian fluid because it obeys Newton's law of viscosity, and Newton's law of viscosity says tau is directly proportional to du by dy. So from here we can say tau is directly proportional to du by dy, or du by dy is d theta by dt. That is Newton's law of viscosity. If b is equal to 0 and n is greater than 1, that is non-Newtonian fluid, which is called as Bingham dilatant. That is dilatant. And if b is equal to 0 and n is less than 1, that is called as pseudoplastic. Now if b is not 0 and n is equal to 1, that is called as Bingham plastic. And if b is not 0 and n is greater than 1, that is called as rheopactic. And if b is not 0 and n is less than 1, that is called as thixotropic. These are the various fluid. The study of these non-Newtonian fluid is called as rheology. Newtonian fluid will be drawn like this. Here it will be du by dy, velocity gradient, and here it will be tau. This is Newtonian A, and this is B, dilatant. This is C, pseudoplastic. Then this is D, Bingham plastic. This is E, and this is F. And when n is equal to, this is ideal fluid and this is ideal solid. This is ideal solid. So this is called as rheological behavior. This is called as, so if b is equal to 0 and n is greater than 1, that is the question. The non-Newtonian fluid is called as dilatant. For dilatant, Bingham plastic, b is equal to 0, n is equal to 1. Newtonian, b is not 0, b is equal to 0 and n is equal to 1. Pseudoplastic, b is equal to 0 and n is less than 1. Dilatant, b is equal to 0 and n is greater than 1. So B is the correct answer. Good evening Maniket, late ho gaye? Welcome. Let us move to the next question. Question number 6. Question number 6. What is the pressure difference between inside and outside of a droplet of water? What is the answer? That is application of surface tension. Sigma is surface tension force per unit length of the common interface, or it can be work required per unit change in surface area. The unit of surface tension is either Newton per meter or Joule per meter square. That is the surface tension. So application of surface tension says, for a liquid drop, or air bubble, both are same. Liquid drop or air bubble, delta P, pressure difference, that is inside minus outside pressure, is equal to 4 sigma by diameter. For a soap bubble, if it is a soap bubble, because there are two interfaces, for a soap bubble delta P is equal to 8 sigma by diameter, and for a liquid jet, delta P is equal to 2 sigma by D. So the correct answer is option B. Question number 6, option B. Well done. 4 sigma by D. Sigma is the surface tension. The unit of surface tension is either Newton per meter or Joule per meter square. As the temperature increases, cohesive force decreases. That is why surface tension also decreases, because it is due to the cohesive force. So surface tension for water air interface is 0.0736 Newton per meter. That is the standard value for water air interface at room temperature. The next one, question number 7. Let me know the answer for question number 7, everyone. Which one of the following is the bulk modulus of a fluid? Bulk modulus. There is a parameter called as compressibility. That is beta. It is the reciprocal of bulk modulus. Beta is equal to 1 by K, where K is called as bulk modulus. What is the unit of bulk modulus? Bulk modulus, the unit is Pascal or Newton per meter square. That is the bulk modulus. K is direct stress upon minus dV by V. So we can say minus dV by V is equal to d rho by rho. Change in volume per unit volume is change in density per unit density. So it will be dP upon d rho upon rho, or we can say rho into dP by d rho is the bulk modulus. Rho into dP by d rho. Rho into dP by d rho. Option A will be the correct. Yes, Ronaldo, well done. Question number 7, option A is the correct answer. If the question asks you about the compressibility, अगर compressibility के बारे में question होता, so beta would have been 1 by K, that is equal to d rho upon rho dP. Compressibility ये होता है, इसका unit होता है meter square per Newton. Coefficient of this is called as coefficient of compressibility. This is called as coefficient of compressibility, d rho upon rho dP. ये होता बीटा. And based on if beta is equal to 0, if compressibility is equal to 0, then the fluid is incompressible. The fluid is incompressible. If beta is equal to 0, it means liquids are incompressible. If beta is not 0, then the fluid is said to be compressible fluid. The fluid is called as compressible. Gases are compressible, because when beta is equal to 0, density is constant. When beta is equal to 0, density is constant. Beta is equal to 0 means d rho is equal to 0. Beta is equal to 0 means d rho is equal to 0. It means rho is equal to constant. And beta is not 0, d rho is not 0. It means density is a function of temperature and pressure. For gases, density varies with temperature and pressure, and for liquids, density is treated constant. It neither changes with temperature nor pressure. Right? So this was about the fluid properties, and we are conducting a scholarship test on 29th of October, the coming Sunday, between 9 a.m. to 9 p.m. you can appear for the test. You just have to register yourself, and the link is already there in the description box, and based on your performance in the scholarship test you can avail the discount in our paid courses. The next one, let us move to the manometry. It is a numerical, actually it is a numerical. Can you quickly solve this? The numerical is simple. It is related to some formula, standard formula. The relation between, this is question number 8 na, the relation between absolute pressure, gauge pressure and atmospheric pressure. The barometer is the instrument which measures the local atmospheric pressure. So the absolute pressure at any point is equal to atmospheric pressure, that is local, plus gauge pressure. Gauge pressure can be positive, can be negative. We can say gauge pressure is equal to absolute pressure minus atmospheric pressure, and atmospheric pressure must be local one. And the pressure can be written as rho GH, or the pressure head can be written as P by rho G. P by rho G is called as pressure head in terms of fluid column. It is pressure head in terms of fluid column. So the standard atmospheric pressure, we do not require the standard atmospheric pressure. We need the local atmospheric pressure. That is one thing you need to take care. And the gauge pressure, if it is given, it should be with sign. And the negative gauge pressure is called as, negative gauge pressure is also called as vacuum pressure, is equal to vacuum pressure. Negative gauge pressure is also known as vacuum pressure. So at a specific location, barometer reads, so gauge pressure we need to find out. The question is to find out the gauge pressure. The barometer reads how much? 700 millimeter of mercury, 700, then minus, sorry, gauge pressure is P absolute minus, the absolute pressure is how much? Absolute pressure of 380 minus 700 millimeter of mercury, isn't it? So gauge pressure is minus 320 millimeter of mercury. Gauge pressure is minus 320. So we can call it as 320 millimeter of mercury vacuum. Vacuum means negative gauge pressure. Option A. Yes, option A is the correct answer. So what you need to remember is, whenever gauge pressure is given, then we can find out the absolute pressure, or when absolute pressure is given, we can find out the gauge pressure, and vice versa. The next is from the hydrostatic law. Question number 9. Question number 9 on the screen. What is the answer to question number 9? Is it C or D? Is it C or D? This is called as hydrostatic law. Both are expressions of hydrostatic law. That is hydrostatic law, right? And Z can be depth or height. So pressure increases with depth. So it will be dP by dZ is equal to rho G if Z is the depth from any reference, and dP by dZ will be equal to minus rho G if Z is a height from any reference. If Z is measured as a height, then it will be minus rho G, and if Z is measured as depth, it will be plus rho G, right? So option C will be the correct answer. And pressure at a depth h for incompressible fluid, pressure at a depth h from the free surface, pressure at a depth from the free surface, free surface when rho is constant. So we can say rho into G into H. That is the gauge pressure at a depth, rho GH. And from here we can get P is equal to gauge pressure by rho of liquid into G. That is called as pressure head. That is the pressure head. क्या मनिकेत, डाउन के लिए प्रेशर इंक्रीजेस विद डेप्थ, सी करेक्ट होगा ना. अपवर्ड के लिए डी होगा, अपवर्ड के लिए डी होगा, डाउनवर्ड के लिए सी होगा, बिकॉज इट इज गिवन एज डेप्थ, राइट? इजंट इट? द नेक्स्ट वन, इसका आंसर पता है आपको, ये सॉल्व कर सकते हैं. That is about fluid in a rigid body motion. Fluid in a rigid body motion. Fluid is moving like a rigid body. When the fluid is moving like a rigid body, what is the answer to this question? कौन सा question number कौन सा? 10. Question number 10. Find out the answer to question number 10. Everyone. ये पता होना चाहिए, वेरिएशन ऑफ प्रेशर इन एक्स डायरेक्शन माइनस रो टाइम्स ऑफ ए एक्स, वेरिएशन ऑफ प्रेशर इन वाई डायरेक्शन माइनस रो टाइम्स ऑफ ए वाई, वेरिएशन ऑफ प्रेशर इन जेड डायरेक्शन, रो इंटू जी इफेक्टिव, वेर जी इफेक्टिव इज इक्वल टू जी प्लस माइनस ए जेड. प्लस साइन कब यूज होगा? AZ is upward. माइनस साइन कब यूज करेंगे? when AZ is downward. प्लस साइन कब यूज करेंगे? when AZ is upward. माइनस साइन when AZ is downward. What is the answer to this one? A beaker of water falling freely under the influence of gravity. Because it is falling, it means there is no acceleration in x direction, there is no acceleration in y direction. If it is falling freely, if it is, the motion is in vertical direction, there is no acceleration in horizontal plane, neither ax nor ay will be there, and it is falling freely, free fall. For the free fall, Az is equal to plus, for the free fall means downward, Az will be equal to minus G, isn't it? For the free fall, because Az is downward. For the downward direction, Az will be negative and it will be minus G. So what if you put the value of Ax, Ay, Az here? If you put the value of Ax, Ay, Az here, then what will you get? Do you agree del P by del X is equal to del P by del Y is equal to del P by del Z? You will get at 0. It means pressure is neither be a function of X nor Y, Z. Pressure remains constant everywhere. For the free fall, pressure will be constant everywhere. किसी ने भी सही जवाब नहीं दिया. A beaker of water is falling freely under the influence of gravity. Point B is on the surface and point C is vertically below, near the bottom of the beaker. If PB is the pressure at B and PC is the pressure at C, then there will be no variation in pressure if the container is having a free fall. Do you guys understand it or not? These are the formula you must remember. This is the variation of pressure in x direction, variation of pressure in y direction and variation of pressure in z direction. A will be the correct answer for this one. किसी को कोई confusion है, you can let me know. If you have any doubt, anything to ask, you are most welcome to share your opinion. And if you do not understand it, I will repeat again if you want. The next one, question number 11. What acceleration would cause the free surface of a liquid contained in an open tank moving in a horizontal track to dip by 45 degree? Again, it is from the rigid body motion of the fluid. Fluid moving like a rigid body. But it is in horizontal direction. It is horizontal acceleration. It is regarding the horizontal acceleration. Let me give you a brief idea about the horizontal acceleration. If there is a container, let us say, and initially it is filled up to this point, this is h, and the total height of the container is, let us say, capital H, and this is the length of the container. It is having, the length of the container is L. If the container is having an acceleration in x direction, ax, I am talking about horizontal acceleration. It means ax will be non-zero, but ay is equal to az will be 0. Ax and ay will be 0. This is the center line. The free surface will become like this. This is the free surface. This is angle theta. This will be the free surface. This will be the new free surface. This is angle theta. Let me call this to be delta H. So from here we can say del P by del X is equal to minus rho AX, and del P by del Z is equal to rho into G. So from here we will get dz by dx, that is equal to tan theta, or we can call it as delta H by L. dz, this is z direction, this is, sorry, ये x direction, ये z direction. So dz by dx, because the pressure variation is linear, so delta H by L is equal to tan theta is equal to ax by g. It is not a function of density of the liquid. ये expression आएगा. For horizontal acceleration, this will be the expression. And for ax to be maximum, for no liquid spill, if we want ax to be maximum, it means delta H should be maximum. What is delta H maximum? The free surface should be like this, then the liquid will start spilling. So delta H maximum will be equal to twice of capital H minus small h. So we can say twice of capital H minus small h upon L is equal to maximum acceleration without spilling by g. This is how we can find out maximum acceleration. Right? Now the question is, what acceleration would cause the free surface of a liquid contained in an open tank moving in a horizontal track to dip by 45 degree? It means theta is equal to 45 degree. So tan 45 degree. So tan 45 degree is equal to ax by g. What is tan 45? That is 1 is equal to ax by g. So ax will be equal to g. The answer will be C. The correct answer will be C. Yes, yes, Mohit, well done. The correct answer to this question will be C. Do you guys understand this concept for horizontal acceleration? I hope you understand. If you have any doubt, you can just let me know. Question number 11, answer is C. Question number 11, answer is C. Question number 12. Question number 12. Solve question number 12. In order to increase the sensitivity, of a U2 manometer, one leg is usually inclined by an angle theta. It is inclined single column manometer like this. This angle is theta. This is inclined single column manometer. What is the sensitivity of the inclined tube compared to the sensitivity of normal U tube? What is sensitivity? Yes, the sensitivity is given by 1 by sine theta, that is L upon H2. this is, let us say, h2, this is L, and this is vertical distance is, let us say, h2. So L by h2 is the sensitivity, 1 upon sine theta. As theta decreases, when theta decreases, sine theta will also decrease, and theta decreases, sine theta will decrease. So sensitivity will increase, sensitivity of the instrument will increase. So B is the correct answer. Yes, no one, Mohit, Hari Sindhu, well done. B will be the right answer. 1 upon sine theta will be the sensitivity of U-tube, inclined U-tube manometer. For theta is equal to 90 degrees, sensitivity will be equal to 1, and it will increase. The value will be greater than 1. It will be greater than 1. The next one, match the list 1 with list 2. What is center of pressure? What is center of gravity? What is center of buoyancy? What is metacenter? What are the difference in these? What is the center of pressure? The center of pressure, Cp, is the point of application of total hydrostatic force. The point of application of the pressure force, it is the total resultant hydrostatic force. Center of pressure is where the resultant hydrostatic force acts. So A will be 3, A3. Center of gravity, where the weight of the body acts. Center of gravity, point at which application of the weight of the body. Center of gravity, G, is the point where the weight of the body acts. B4. Center of buoyancy, where the buoyant force acts. And what is buoyant force? It is the buoyant force is equal to weight of the displaced fluid. It is the weight of the displaced fluid. So point of the application of the weight of the displaced fluid, and weight of the displaced fluid is called as buoyant force. Weight of the fluid displaced is called as buoyant force. So C1. And D, metacenter. Metacenter is the point about which a floating body oscillates. The metacenter is the point about which the floating body starts oscillating when it is tilted by some angle. That is 2. A3, B4, C1, D2. 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2. C will be the correct answer. 3, 4, 1, 2. क्या हरी सिंधु 3, 4, 1, 2 होगा ना? 3, 2, 4, 1 कैसे हुआ? 3, 4, 1, 2. It will be 3, 4, 1, 2. Isn't it? It will be 3, 4, 1, 2. 3, 4, 1, 2. Right? Now the depth of center of pressure for a rectangular lamina immersed vertically in water up to height h is given by. What is the answer to this one? Question number, कौन सा number है? Question number 13 and 14. Question number 14. Question number 14. Tomorrow we will have the discussion about part 2. Tomorrow will be part 2. ये h by 2 है, ये है x bar. It is depth of centroid. X bar will be the depth of centroid, and depth of center pressure. The question is about the depth of center pressure. अच्छा, आपने ऐसे लिखा है A3D2. अच्छा, ये डेप्थ ऑफ CP, HCP, डेप्थ ऑफ CP फ्रॉम फ्री सरफेस. ये depth of CP from the free surface. How to find out? X bar में क्या आता है? You should memorize. You can memorize this. X bar में आता है 1 by 2h. If we add 1 in the numerator, 1 in the denominator, that it will become HCP. So it will be 2h by 3. That is the depth of center of pressure. Center of pressure always lies below the center of gravity. This is the free surface, let us say. Center of gravity यहाँ lie करेगा, that is x bar. I am calling it as x bar. And the location of center of pressure will be slightly below center of gravity. That is HCP. So it is more than h by 2. It will be more than h by 2. H by 4 cannot be correct. 2h by 3. C is the correct answer. Next one, for a triangular plane surface, for a triangular plane area submerged in water, for a triangle के लिए भी 1, वैसे ही one side in free surface, vertex downward. If the vertex is downward, how to memorize? Find out the location of x bar. What is x bar? Isn't it x bar is equal to h by 3? H by 3 is x bar, depth of centroid. It will be depth of centroid. And how to find out HCP? So it is 1 by 3h, add 1 in the numerator and add 1 in the denominator. That is the trick to memorize. HCP, that will be equal to 2h by 4. That is equal to h by 2. H by 2 will be the answer. D will be the answer. D will be the correct answer for a triangular plane area. This is the free surface. This was question number 15, right? Question number 16. Find out the answer for question number 16. The vertical component of force on a curved surface. Whenever we are having a curved surface AB, if we want to find out the vertical component, then what we need to do is to get the vertical component, extend the edges normally up to free surface. The weight of the fluid which can be contained, the weight of the fluid which can be contained by the curve normally up to free surface is vertical hydrostatic force. If the fluid is from top, then it will be downward. If the fluid is in contact from the bottom, then it will be upward. But the magnitude will be the weight of the fluid which can be contained by the curve up to free surface. ये सेशन अभी खत्म हो जाएगा, next 10 minutes. Ronaldo, by 9 o'clock we will wrap it up. What is the answer for question number 16? It is the weight of the liquid above the CG of the curved surface. Weight of the liquid above the curved surface. Product of pressure at CG multiplied by the area of the curved surface. So the correct answer is weight of the liquid above. हाँ वो कैंसिल हो गया. Saturday को है सोम. मोहित, सोम is on Saturday. Today and tomorrow it is fluid mechanics part 1 and part 2, right? B will be the answer. For horizontal component, what we are supposed to do? If you want the horizontal component, then take the vertical projection of the curve. Take the vertical projection of the curve. For horizontal, take the vertical projection, and vertical projection will be treated as a vertical plane surface. So that is how we will get FH. And it will pass through CP for the vertical projection. So the resultant force will be equal to under root of horizontal force square plus vertical force square. That is the total hydrostatic force or the resultant hydrostatic force. ये तो simple है. What is the answer to this? What is the depth of centro pressure? H bar is actually the depth of centroid here. Depth of centroid from free surface. What is the answer? It is simple. H bar plus Ig by, so HCP, depth of central pressure, is equal to x bar plus Ig by A x bar, or if we can write it H bar plus Ig by A H bar. That is the depth of central pressure. That will be the depth of central pressure. That will be the depth of central pressure. For vertical surface, it is for vertical surface. The general expression is HCP is equal to x bar plus Ig by A x bar sine square theta. The general expression is this. This will be the general expression. X bar plus Ig by A x bar sine square theta. A is the correct answer because it is a vertical surface. So we can say for vertical surface, theta will be equal to 90 degree. So sine 90 will be equal to 1. So HCP will be equal to x bar plus Ig by A x bar. For a horizontal surface, if it is horizontal surface, then theta will be 0 degree, then sine 0 will be equal to 0. So HCP is equal to x bar. For horizontal, it will be x bar. For vertical, it will be x bar plus Ig by x bar. And there will be an important workshop on 1st of November, that is Wednesday, taken by Abhinav Negi sir, about the preparation strategy to become the GATE topper in 2025. This session is important for all those aspirants who are preparing for 2025, right? You just have to register yourself for this workshop and the link is already there in the description box. Next question on your screen. Stability and condition of stability for a floating body, for a submerged body. For a submerged body and for a floating body, stability condition. What you need to memorize for submerged body? BAG, the center of buoyancy must lie above center of gravity. For floating body, for a floating body, MAG, meta center must lie above center of gravity, like this. So this is the short trick to memorize. Theoretical question can be framed. For a completely submerged body, center of buoyancy must lie above center of gravity for stability, and for a floating body, stability condition is meta center must lie above the center of gravity. Meta center is the point about which the floating body oscillates. So stable equilibrium of a floating body, meta center must lie above G. For a floating body, meta center must lie above G. 2, A2. Stability condition for a submerged body, center of buoyancy must lie above center of gravity. Center of buoyancy above the center of gravity, 3. Unstable equilibrium of the floating body, meta center must lie below. Unstable means meta center is lying below G. Meta center is lying below G, 4. For unstable equilibrium of a submerged body, G lies below B. Center of gravity or center of buoyancy lies below center of gravity. Center of buoyancy below center of gravity, 1. 2, 3, 4, 1, isn't it? 2, 3, 4, 1. B is the answer. For a completely submerged body, you should memorize. For a completely submerged body, you should memorize BAG, center of buoyancy must lie above center of gravity, and for a floating body, MAG, meta center lies below, meta center lies above center of gravity. What is the metacentric height? What is the formula for metacentric height? Question number 19. What is the formula for metacentric height? Statics is most important actually. Statics is the topic which is most important for your examination. Metacentric height, GM is equal to BM minus BG, where BM is equal to Ixx upon volume of fluid displaced. GM is called as metacentric height, and based on GM, if GM is, so it is I upon V minus BG. C is the correct answer. V is the volume of the fluid displaced, and I is the moment of inertia of the plane of the floating body at the water surface, that is Ixx minimum, I minimum. It is actually Ixx is I minimum, minimum moment of inertia. And based on this, we can say if GM is can we say if GM is positive, if GM is positive, or we can say if BM is greater than BG, then the body will be stable. If GM is equal to 0 or BM is equal to BG, then it is neutral equilibrium. it is neutrally stable, and if GM is negative or BM is less than BG, then the floating body, it is about a floating body, then the floating body will be in unstable, right? And the body oscillates about the metacenter. How to find out the time period of oscillation? The time period of oscillation is given by 2 pi under root of Rg square upon G into Gm, and this is the time period of oscillation. Time period of oscillation. This is the formula for time period of oscillation, right? And Gm can also be calculated experimentally. W dash into x upon W tan theta. Gm can also be, where W dash is jockey weight. It is jockey weight. X is the displacement. And theta is angular displacement of the jockey weight. And W is weight of the ship. Weight of ship. So Gm can be calculated experimentally by using this formula. So these are some important formula. Now the kinematics. Yes, question number 20 from the kinematics. Fluid flows steadily through a variable area duct. The duct is having variable area. This is, let us say, section 1, this is, let us say, section 2. The fluid is flowing through a variable area duct. At section 1, density is ρ1, cross-sectional area is A1, velocity is V1, and pressure is P1, and corresponding values at section 2 are ρ2, A2, V2 and P2. Then the following relation is satisfied. Which of them is correct? Which of them is correct? A1 V1 is equal to A2 V2 when rho is constant for incompressible fluid. This is the continuity equation for one dimensional and incompressible. Rho1 V1 square by 2 is equal to ρ2 V2 square by 2 is valid when P1 is equal to P2 and Z1 is equal to Z2. P1 is equal to P2 and Z1 is equal to Z2. That is the energy conservation equation. P1 A1 is equal to P2 A2 when the forces are equal. C will be the correct answer. Mass flow rate at 1 is equal to mass flow rate at 2 for the flow to be for steady flow. For the steady flow and compressible flow. C is the correct answer. For incompressible, A is correct. For compressible and steady, C is correct. Because ρ1 and ρ2 are given different. It means the flow is compressible. And that is why option C will be the right answer. So let us stop here only. The remaining part we will continue in tomorrow's session. Right? The remaining discussion we will have in tomorrow's session. So there are crash course running on our BYJU'S platform, as well as there is a Vision Gate 2025 and 2026 are also running. If you have not joined me on the Telegram, you can join me on the Telegram. I will share the PDF of this session as well. Right? So see you tomorrow at 8. Tomorrow at 8 p.m. we will meet again for discussing the fluid mechanics part 2. Right? Thank you very much, Hari Sindhu. So tomorrow will be more important session because most of the students have difficulty in memorizing the formula from the laminar flow, turbulent flow. real flow, dynamics. Problem is with the dynamics. Statics, everybody can memorize easily, right? So do not forget to join me tomorrow at 8, and please come prepared. Please revise before coming to the session, and that is all from my side. See you tomorrow at 8. Till then, enjoy, take care, have a good night, Shubh Ratri, Sabba Khair and Jai Hind. अच्छा, पूरी सीरीज के इंफॉर्मेशन चाहिए क्या आपको? ये शेड्यूल चाहिए क्या आपको? टेस्ट सीरीज, अच्छा टेस्ट सीरीज अभी प्लान नहीं किया. टेस्ट सीरीज जैसे ही प्लान होगी आई विल लेट यू नो. ठीक है, थैंक यू गाइज, थैंक यू वेरी मच.